Welcome back to Algebra 2. If we take a look at these and we think about them in terms of what number for the exponent would 2 to what exponent would give me 4, we should be able to figure out most of these thinking about the rules of exponents. Stop the tape and try that now. So 2 to what power gives me 4? 2 squared gives me 4, so I'm going to say the value of x is 2. 8 to what power would give me 1? Well, 8 to the 0 power, because anything to the 0 power would give me 1. 2/3 to what power gives me 8/27. 2 to the 3rd power, 3 to the 3rd power. Now we're starting to get into some other fractions and lower numbers. If I want to take the 4 and put it in the denominator, I have to have a power of -1. I'm taking the square root of this, and the square root is the half power, because the root is in the denominator. And now I'm taking the half power, but I also need to put it in the denominator, so this one will be -1/2. So I will be going back over a lot of the rules for exponents as we go through this chapter. We're going to convert between exponential and logarithmic forms and be able to evaluate logarithms both by hand and using calculators. Well, the first part of that is to know what the heck a logarithm is. We've already done inverse functions. What we did in finding an inverse function was we swapped the x and y's, we solved for the new y, and what we actually did graphically was flip the graph over this green line, y equals x. The logarithm is the inverse of the exponential function. So the blue one is the exponential, the logarithm is its inverse. So what we do is we use these logarithms in order to solve exponential functions. First, we got to get used to just dealing with them. So we have two different forms here, and I'm going to show you a couple different ways to try to deal with this. Log base b of y equals x. And then here, b to the power x equals y. Those two things are swapped. I'm going to show you a couple different ways to think about that. This is the first one to go between exponential form and logarithmic. The base goes down below. It's a sub number. And x and y swap places. I just found this week, and I like it a lot. Log base answer equals exponent. Log base answer equals exponent. So these are the two things we're going to look at to try to swap things around. The base has a very specific spot, and x and y swap places. So let's take a look at what that would look like a little bit. If we want to rewrite this as an exponent, we have to start with the base. It's taken to the power on the other side, and that equals 16. And that is a true statement. So base, I need to find the exponent, which is over here, equals the answer. Base to the exponent equals the answer. And in this case, the base is 1/4. Since it's ugly, put it in parentheses, to the -1 power equals answer. So you will be converting these logs to exponents. We're also going to go the other way. So now the exponent has to go on the other side, and we have to write our little log. The base is down below. Then the answer is at the same level as the log, and it equals the exponent. Let's do a couple more like that. We know we're going to have the log, base down below, answer equals exponent, base down below, answer equals, and I do like fractions written vertically. And our last one here, base is 6. And since this is a little bit complicated, and I do want to make sure I write it in the right places, put it in parentheses, equals the answer. All of those are true. They are inverses of each other. Just wrote the logarithmic form. Evaluating, we often still want to think this. 4 to what value would give me 64? 4 squared is 16, 4 cubed, so x equals 3. 5 to what power would get me, and I'm going to write this as a fraction so we can actually see it. So I need to put it in the denominator, which means I need a negative number. So we have 1/5. Complex, put it in parentheses. So 5 to the 3rd power would get me this. I need to bring this up. That means I need to have negative 3rd power. And our last one, 36, to what power would get me 6? Well, that needs to be square rooted, and square rooting is put it in a fraction. The denominator is the root. So those are all evaluations that we can do by hand, and you should be doing by hand. So the basic logarithm form is here. There are 2 other forms of a logarithm. The first one is the one that the calculator does. So it's log n. There's no base because the base is 10 and we count in base 10. The other one deals with e. It's called the natural log, and to state that compared to the common log, we use ln, and that's the button that you'll find on the calculator. So ln is the inverse of e. Now, if we're evaluating these, notice there is no base because the base is assumed to be 10. You are going to grab a calculator. And in our calculator, you'll see these 2 buttons here, log and ln. So if I want to find the log of 8, that is 10 to what power gives me 8. So for a, log of 8 is 0.903. Then for b, ln is a different button. ln is here, and that's going to be a 0.3, and that is negative 1.2039 becomes 4. So evaluating and rounding, these are the 2 buttons we're looking for. What you will notice is log doesn't give you the opportunity to put a base in. So the calculator has some limits. The next thing that we have is how do we get rid of logs and bases? And we get rid of them by doing the inverse. These 2 are both examples of inverses. So log base b of b to the x power is x. The log base b and the b, those 2 things will cancel each other out. I can also start with the exponent, then do the log. Have to have the same base here, and those things cancel out. 8. 3 to the log 3, that's the part that cancels, and we're left with just what's inside. So these two things annihilate each other. If we do not see the base 10, it's there. So 10 to the log 10, A is going to equal 4. It looks ugly, but it simplifies. Now here, I don't have a 5 here, so I want to rewrite B in a way that I can see that. And I'm going to do log base 5. And what I need to change is 5 squared is 25. Going back to my x. Now my rules of exponents tell me to multiply these things. So now I have log base 5 of 5 to the 2x power. And this part cancels, so B, the answer is 2x. They're ugly looking, surprisingly clean up nice. So if I'm finding the inverse of a function, I very specifically put the x where the y is. Remember, y is f of x. Put the y where the x is. And I need to rewrite this. So the inverse of an exponent is a log. It is base of the answer equals the exponent. If I am swapping these guys out, x here, ln, y here inside. So I need to start by converting this. ln is a base of e to the exponent equals what's inside. Then I need to move this 3. So I get e to the x minus 3. So those are writing the inverse statements between exponential and logarithmic inverses. Simplifying expressions, what does this become? It becomes x. This one becomes just the exponent, which is negative 3x. E to the ln, those are going to cancel, left with 20. 64 is 2 to the 6th power. So I'm going to multiply the powers. Log base 2 of 2. This simplifies to 6x. Write the inverse. So I need to do the log base 4. And I need to swap these positions. So it becomes x here equals y. Swap the positions. So we have x here, y here. This is a e to the x power equals y minus 5. That means I'm going to add 5 to the other side. So I'm going to add 5 here, and that is the inverse equation. Okay, your homework is in the book. I will attach the book on this. And we will have homework help on Wednesday morning, and you need to be ready to ask questions. Have a good day.